Welcome to today's edition of the San STEM Quarantine Lab. Hello. Today we are going to demonstrate electrical transformers and high voltage electricity. But before we get started on that, let's take a look at Dr. Frankenstein's lab in 1931. So what you saw in Dr. Frankenstein's movie was electric arcs created from 2,000 to maybe 10,000 volts of electricity. Now that's some serious, dangerous electricity. That's the kind of electricity that can it's very deadly. Let's put it that way. Anyway, you remember your lecture on electricity, where the voltage is like the height of a waterfall. Well, we're going to use this little experiment right here to create a 2,000 volt spark that travels up these wires, just like in Dr. Frankenstein's lab. However, remember, this kind of stuff is very dangerous, and the 2,000 volts of electricity we're going to create here is like a really tall waterfall, and you don't want to get hit by that tall waterfall. Basically, it'd flatten you like a pancake. So now let's talk a little bit about a transformer and what it looks like. It's actually a simple machine that has no moving parts, but it can take electricity of one voltage and convert it to electricity of a different voltage. So in this picture right here, you have this blue object that's a metal frame that is a good conductor of magnetic fields. Now here, this is the primary winding. This is where electricity comes in, it winds around the metal frame 4 times and comes back out. Now over here we have the secondary winding. Here the wire comes in, it wraps around 10 times and goes out. And so what happens is when electricity is applied to this side and it goes around the metal frame, it generates a magnetic field. This magnetic field flows over to this side of the frame, and that magnetic field, when it comes in contact with these wires, it does the exact opposite of the primary winding, and that magnetic field induces a current in these wires. And the cool thing about a transformer is that the number of turns of the wire on this side, if it's greater than the first side, then it will increase the voltage. If it has fewer number of turns, it'll decrease the voltage. So the transformer, this purpose is to convert voltage of one level into voltage of a second level. So the math of a transformer is fairly simple. Basically, we have the voltage of the primary side divided by the number of turns over here of the primary side is equal to the voltage of the second side divided by the number of turns on the second side. So here's our equation. So oftentimes we know the voltage that we're putting into the machine and we know the number of turns. So we want to figure out what happens coming out. So to solving for the voltage of the secondary coil, we come down here. And so if we were to plug some numbers into this equation, we could say, for example, we are supplying 120 volts of electricity divided by the 4 turns and multiplied by the 10 turns, and that would give us 300 volts of electricity. So in this case, this transformer right here, if we applied 120 volts here, we would get 300 volts on the output. So now that you know a little bit about transformers, let's take a look at our project here. So it's a pretty simple project. We have our on-off switch, we have our transformer, and we have our electrodes that we're going to make the spark. But let's take a closer look at the transformer. So this transformer, you see the power is coming into this side of the transformer, and this is the primary coil. It actually has 90 turns of electrical wire. And then over here we have our secondary
coil. This one here, it's hard to see, but it uses thinner wire, and it gets 1,650 turns. And it's kind of covered up because what we're going to get out of this side is extremely high voltage. So let's look at the math again. Back over here, we have our equation. We have 120 volts coming in. We have 90 turns. We multiply that by 1,650 turns. We're going to end up with 2,200 volts. Now that is some serious electricity. So now that you have learned a little bit about what a transformer does and how it works, let's see it in action. What we have here, I turn the switch on, the transformer is hot, so I don't want to touch any of this high voltage stuff, but what I have here is a nail to actually start the spark. And if I touch these two wires, the spark will start and travel up and dissipate. So here it goes. Get ready. This is called, the experiment is called Jacob's Ladder. And remember, do not try this at home, but let's keep looking at it. Thank you for watching the San Marin STEM Quarantine Lab. Hopefully you learned a little something about high voltage and transformers. Be well.